Good evening. Today we're going to be heading into some new territory. So we're going to be completely heading out of area and we're going into volume. So today our video is going to be about volume. And a volume is only dealing with three-dimensional objects. So the first thing you need to know that your background knowledge in volume is length times width times height. When you were in maybe 6th grade, you may have briefly touched on volume, and the thing that you knew about it was you take the length, the width, and then you add in that third dimension, and it's the height, and that gives you an object's volume. And so volume, the units are going to be in cubic units. Area was in squared units because it's just 2 dimensions. It was like length times width or base times height, 2 dimensions. Now we're adding in a third dimension, so that's where it's 3D objects. So you get cubic units. An example would be meters cubed, centimeters cubed, feet, cubic feet. You might hear them called that. So cube means to the 3rd power, and that just means like this would be meters times meters times meters. This is centimeters times centimeters times centimeters, and feet times feet times feet. Okay, so that's where those. That's what you need to know to begin with. So again, just like an area, you will have formulas. So there's 2 formulas in 7th grade that you need to know, and then there's going to be a few more for your 8th grade material that you need to know, but only 2 of them will be on the 7th grade STAR test that you take this year, and that is the volume of a prism and the volume of a pyramid. It doesn't matter if it's a rectangular prism, a triangular prism. It doesn't matter. The formula is the same for all prisms, and then for pyramids it's the same. It doesn't matter if it's a rectangular pyramid or a triangular pyramid. Okay, so we're going to go ahead and write those formulas in our notes. So I'll write them for you. So first we have a prism, and the formula is V, capital V, which stands for volume. V equals capital B times H. Make sure it is capital B. Okay? And we're going to make a little note. This is not just one dimension. This capital B is different from a lowercase b. A lowercase b is just one dimension. It's just the base. A capital B means it's the whole bottom layer of a 3D object. It's the whole base. So with a rectangle, so it's the base layer. With a rectangle, I'm going to draw in a 3D object. Let's see here, hope you'll be able to see this, hopefully. Let's see. So here's a rectangular prism, okay? So the big B base would be like the whole, this is your big B base. This whole base. Okay? So that really means with a rectangle, a big B base is length times width. It's the area. It's the area of the base. Okay? It's the base layer. And yes, I know I'm drawing the top of it, but you know this could be a base as well if you just flip it. Okay? So this whole thing is your big B. Okay? Then the little h is the same as it was to begin with. It's just height. It's the height of the three-dimensional object. So this is your h, your height. Okay? So I'm going to do an example. I also wanted to draw in a triangular pyramid. Okay, so okay, so that's a triangular pyramid. It helps me to do these dotted lines for you so you can see the third dimension. Okay, so this is a triangular pyramid, a prism, sorry, prism. It has triangular bases. So the big B would be this whole base of the triangle. Okay, this is your whole big base. So of a triangle, the big B would be little b times height divided by 2. Okay, it's just that area of the triangle. Alright, so the height of the, and then you would just multiply it by whatever your big B, whatever is your big B, which is that bottom base layer of the triangle. It would be that times, the height of the pyramid, which this is actually the height. If you stood it up on the base, this is how tall it is, not this. Okay, so I'm going to do an example. Let's say, using those same three-dimensional figures I just drew, let's say that this is 10 centimeters. So that means this is 10 centimeters across the length. This is 3 centimeters. Okay, and the height is 5 centimeters. Okay, so we could get the volume by writing our formula, big B, the base, times the height. Okay, so first we're going to get the big B. And the big B for a rectangle is going to be this up here, its base. So that will be 3 times 10, and you get 30 centimeters squared. Okay, so because centimeters was our unit of measurement. So now our height is how tall that 3D object is, and it's 5 centimeters. So now our volume becomes the big B, which is 30 centimeters squared, times 5 centimeters. And you get 30 times 5, which equals 150 centimeters. And since you're doing centimeters squared times another centimeters, that becomes cubic. That's where that cubic comes in. That's 3 different dimensions. And that is your answer. That would be the volume of this rectangle. This rectangular prism. Okay? Now I'm going to do an example over here with the triangular prism. You have 5. The height is 5. the height of the whole prism is 8. Okay. And so now we're going to do the big B first. Oh, let's write it again. It's big B times H. Big B equals base times height divided by 2. So that is the base. Now we're just looking at the base of the triangle, okay? The base is 5 times 5 divided by 2. So you get 5 times 5, the height, you get 25 divided by 2, which is 12.5. You can't see that. This is 12.5. Okay? So your big B is 12.5. And your height of the whole thing is 8. And these are in feet. Sorry. So 8 feet. So now it's V equals 12.5 squared feet. That was your big B. Times your height, which is 8 feet. And that equals my calculator here. 12.5 times 8, 100 cubic feet even. So that's of that triangular prism. Okay? So that's all we're going to do for tonight. And tomorrow we're going to be talking about pyramids, the volume of pyramids. All right? Have a good night.